So I'm going to talk about future Open RAN. So the intelligence and challenges coming along with it. Well, this is slightly a big topic in communication, but I just want to give the basic flavor of it. So what is RAN? So RAN stands for Radio Access Network. It's part of the communication network connecting what we call the user equipments to other parts of the network. Well, for example, when we use mobile data to connect it to the web service, we are connecting through the RAN. So let's take a look at what are the user equipments and applications we talk about. For example, in self-driving vehicles, it requires ultra-reliable communication service with low latency to guarantee that it has a fast response and to guarantee safety. But for other applications, for example, for video streaming, the main requirement will be the enhanced broadband. And not to mention, we have massive IoT, the Internet of Things, which is developing rapidly in recent years. So these network applications initially have very different requirements to the network. So the network itself is evolving to handle all of them in a more efficient way. Well, on the left side, here are some directions of the RAN evolution in the past several decades. Clearly, it's not feasible to design different network architectures for different applications. So to support fundamentally different applications, RAN is being virtualized and moving to a software-defined network. So it's basically a disaggregation between the software and hardware. Recently, we have standard and open control interfaces. This is what we call the O-RAN. And currently, the O-RAN Alliance is working on defining the architecture, interface, functionality split, things like that. Well, an important innovation introduced by O-RAN is the RAN intelligent control. So for the first time, network functionalities can be designed as apps and plugged in through these open interfaces. So this creates open ecosystem. It's not vendor specific. Instead, it's vendor neutral. So designing network functionalities will be kind of similar to designing apps for the App Store, and they can run across multiple platforms. The next point I want to mention is for the intelligent control, the AI machine learning, especially machine learning methods, are considered in the O-RAN for strategic decision making. Well, because it's a good way to use data, it's requiring less human intervention. Well, in our group, we focus on deep reinforcement learning, a sub-area in the machine learning community. So here are two figures showing the previous network control without the RAN intelligence and what we hope to happen in the future O-RAN ecosystem. So previously, we need to involve a human in this loop, and the response will be in a kind of a large time scale. But with the RAN intelligence, so featuring the O-RAN, it will build the self-learning and self-control loop by itself with a certain level of human intervention. So apparently it will be more flexible, and they can deal with like dynamic environments in this way. Okay, so then we move to the challenges. So first is about how to get data acquisition, especially for the reinforcement learning algorithms. It will require interactive data, but interacting with a live network will be super risky. And the second issue is the data privacy. We want to make our models flexible enough, but without causing any privacy issue. So, for example, federated learning might be a good way forward. A third challenge is that because it's a communication system, so it will have bandwidth and latency limitations. So this will put some limit on the complexity of the model we can use, and how do we like train or deploy our model. Last thing is about model maintenance, how to deploy the model, how to manage model, and how to update the model when environment changes. So lifelong learning might be a good way, so we can evolve our model with the change of the environments. So that's all I want to talk about the future Open RAN challenges and intelligence brought by the intelligent control. And thank you very much. Thank you for our founders and the NGCDR project.